There is a particular kind of darkness that exists only in certain moments of human history. Not the darkness of a room or a cloudy night, but the darkness of a doorway through which no one has ever passed, a threshold between everything familiar and everything unknown. Most of us spend our lives on the comfortable side of that doorway. We look at it sometimes. We wonder what lies beyond it. And then we go about our days, grateful for the warmth of the life we already know. But there have always been a few people, just a few in every generation, who walk through, who step across that threshold without any certainty of what waits on the other side, and without any guarantee that they can ever find their way back. Tonight, we are going to think about one of those doorways, the most final one our species has ever contemplated. Not a journey to an unknown continent, not a voyage across an uncharted ocean, something further and more permanent than any of those things. We are going to think about the first human beings who will set foot on Mars, and about a possibility that most people have not fully allowed themselves to consider, that those men and women, whoever they turn out to be, may never come home. If you find these questions about humanity's future among the stars to be worth exploring, you might take just a gentle moment before you sink too deeply into rest to like this video or subscribe to the channel. It is a small and simple thing, and it helps these conversations find the people who are lying in the dark right now thinking about exactly these kinds of questions, just while you are still awake enough to remember. And then we will begin. So let your body settle. Let the weight of your arms and legs ease into whatever is beneath you. There is nothing you need to do tonight, nowhere you need to be, nothing that needs solving before morning. Just this voice and these ideas, and the vast and patient dark. Let us begin by thinking about a pattern that has held true for every expedition, every voyage, every journey into the unknown that human beings have ever undertaken. Think of it this way. Every explorer who ever lived had something in common with every other explorer, no matter how different their destinations or their centuries or their methods. They left, and then they came back. Magellan's crew sailed around the entire world and returned to Spain in 1522. Edmund Hillary climbed Everest to its highest point and then descended back to base camp. The Apollo astronauts traveled 250,000 miles to the surface of the moon and came home a week later, splashing down in the Pacific Ocean while the world watched and cheered. The return was always part of the story. You go out, you push past the edge of what has been done before, and then you come back to tell the story. That is how exploration has always worked, throughout all of recorded human history. Mars might be the place where that pattern finally breaks. Consider the moon for a moment, because the moon is the only other world our species has ever visited. And the contrast between the moon and Mars is essential to understanding why the two things are so fundamentally different in scale and in consequence. The moon is close. Not close in the sense of a drive across town, but close in cosmic terms. About 239,000 miles. The Apollo astronauts reached it in roughly 3 days. The entire mission, from launch to splashdown, took about 8 to 12 days depending on the specific flight. And throughout all of it, Earth was right there, visible from the lunar surface, hanging in the black sky like a luminous marble, blue and white and heartbreakingly beautiful. The astronauts were never more than a few days from home. If something went wrong, if an instrument failed or a crew member was injured, help was at least theoretically possible. The communication delay between Earth and the Moon is about 1.5 seconds. Ground control could talk to the astronauts in something close to real time, guiding them through problems, making decisions together, offering the kind of immediate human presence that makes an impossible situation feel slightly less impossible. Mars is not like that. Mars is not like that at all. Mars is on average about 140 million miles from Earth, but that average conceals a range that matters enormously for any mission, because Earth and Mars both orbit the Sun, and as they do, the distance between them constantly changes. At their closest, a moment called opposition, Mars is about 34 million miles away. At their farthest, when the two planets are on opposite sides of the Sun, That distance stretches to nearly 250 million miles, and the journey, regardless of which end of that range you are working with, takes between 6 and 9 months. Not 6 to 9 days. 6 to 9 months. Half a year or more of traveling through empty space, confined inside a spacecraft, breathing recycled air, eating stored food, watching Earth shrink behind you until it is no longer a world but simply another point of light in the dark, indistinguishable to the naked eye from any of the other lights scattered across the sky. Think about what 6 months means. Think about the last 6 months of your own life. How many meals you ate, how many conversations you had, how many nights you slept in a familiar bed, how many times you walked outside and felt the weather on your face, heard birds, smelled rain on warm pavement. 6 months of all of that, compressed into a small metal vessel moving through a void so complete and so cold that no human concept truly captures it. And at the other end of those 6 months, there is no possibility of simply turning around if something goes wrong, no quick abort back to Earth, no cavalry coming over the horizon. The crew is, in the most literal sense imaginable, on their own. The communication delay alone changes everything about the nature of the mission. When Mars is at its closest to Earth, a radio signal takes about 3 minutes to cross the distance. 3 minutes there, 3 minutes back. That is 6 minutes minimum for any exchange of information. When Mars is farther away, that delay stretches to 20 minutes in each direction, 40 minutes for a single back-and-forth conversation. Imagine trying to ask for help with a technical emergency and waiting 40 minutes for a reply, by which time the emergency has either resolved itself or already become catastrophic. There is no guidance in real time. There is no talking someone through a crisis step by step. There are only messages sent into the dark and the long silence while waiting to hear back, and the knowledge that whatever happens in that silence, you are the only one who can address it. This is the first layer of the problem: the distance, the time, the isolation, and it applies to simply getting there and getting back before we have even considered what landing on Mars actually involves, or what it requires to survive there, or what would be necessary to manufacture enough fuel on the Martian surface to bring anyone home. Landing on Mars is one of the most technically unforgiving challenges in all of space exploration. The difficulty comes from a specific and unhelpful feature of the Martian atmosphere. It is simultaneously too thick and too thin. It is thick enough to create significant heat during a descent, which means any spacecraft entering it needs a heat shield to prevent burning up. But it is too thin to do what Earth's atmosphere does for returning capsules, which is to slow the spacecraft down enough that parachutes can handle the rest. Mars has only about 1% of Earth's atmospheric density. A parachute that would gently lower a capsule to the ground on Earth barely does anything on Mars. You need rocket engines firing in precisely the right sequence at precisely the right altitude. You need timing accurate to within seconds. You need every component of a complex automated system to work perfectly, because the radio delay means that no one on Earth can intervene. By the time Mission Control sees the spacecraft entering the Martian atmosphere on their screens, the spacecraft has already been on the surface for several minutes, either intact or destroyed. NASA calls the entry and landing sequence the 7 minutes of terror, 7 minutes during which thousands of automated decisions are made and nothing can be adjusted from the outside. The crew is passengers during those 7 minutes, trusting systems that were built and tested on Earth, hoping that the simulations and the laboratory testing and the engineering calculations all translate correctly to the actual conditions of an actual Martian atmosphere on an actual day that no one has ever experienced before. And then, let us say it works. Let us say the heat shield holds, the parachutes deploy at the right moment, the retro rockets fire correctly, and the spacecraft touches down on the Martian surface. Let us say the crew is intact, the instruments are functioning, and the landing site is exactly where it was planned to be. They are on Mars. They are the first human beings to stand on another planet, experiencing something that no one in all of human history has ever experienced. The rust-colored sky above them, the rocky desert stretching to every horizon, the sun, small and distant and pale, tracing its arc through an atmosphere so thin it is barely there. It is an achievement that will be remembered for as long as civilization exists. But now, the question that matters most begins to press itself forward. How do they get home? Getting off Mars is, in certain respects, nearly as difficult as getting there in the first place. You need a rocket capable of lifting off from the Martian surface, accelerating to escape velocity, and beginning the long journey back toward Earth. That rocket needs fuel. Substantial fuel. Far more fuel than could reasonably be brought along on the initial trip, because the spacecraft that carried the crew to Mars used most of its propellant during the descent, burning through it to control the approach and land safely. What remains is nowhere near sufficient to escape Mars's gravity and set course for home. So you would need a separate vehicle, a dedicated ascent rocket, pre-positioned on the Martian surface, fully fueled and waiting. And to get that vehicle there, you would need to send it ahead of the crew, perhaps years ahead, have it land successfully in the harsh Martian environment, and ensure that it remains functional through temperature swings of 200 degrees or more, through dust storms that can reduce sunlight by 90%, through months or years of radiation exposure, through the gradual degradation that affects every mechanical system left in a difficult environment without maintenance. And even that is not the hardest part. The hardest part is the fuel itself. Think about what it takes to launch a rocket. The Saturn V that carried the Apollo astronauts to the moon weighed approximately 6 million pounds when fully fueled. Of that enormous mass, roughly 93% was propellant. The actual module that went to the moon and back was a relatively small fraction of the total, and that was for the moon, which has 1/6 of Earth's gravity and no atmosphere at all. Mars has 38% of Earth's gravity, stronger than the moon but still substantial, and it has that thin atmosphere which creates drag during ascent. Getting off Mars requires significant propellant, and you cannot bring that much propellant from Earth. The mass would be prohibitive. The more fuel you try to land on Mars, the heavier your landing vehicle becomes, and the heavier the landing vehicle becomes, the more fuel you need to land it safely, which makes it heavier still. The numbers form a circle. That closes in on itself. The proposed solution is to make the fuel on Mars, to use Martian resources, primarily carbon dioxide from the thin atmosphere and water ice locked in the soil, to manufacture rocket propellant on the surface. The chemistry works. Carbon dioxide can be captured from the Martian air, which is about 95% carbon dioxide. Water ice exists in the Martian soil and in permanently shadowed regions near the poles. From these materials, through a series of chemical reactions that have been well understood since the 19th century, it is possible to produce methane and liquid oxygen, which together make a highly effective rocket fuel. The Sabatier reaction, discovered by the French chemist Paul Sabatier in 1897, takes carbon dioxide and hydrogen and produces methane and water. The water can then be split by electrolysis into hydrogen and oxygen, and the hydrogen fed back into the reaction to produce more methane. Given a continuous supply of carbon dioxide from the Martian atmosphere and a source of water ice, the process can theoretically run continuously, building up a stockpile of propellant over months or years. The chemistry is not the hard part. The hard part is doing this chemistry autonomously, reliably, over a period of 18 months or more, on the surface of another planet, with equipment that was built on Earth and landed without human supervision, in conditions that would test the limits of any mechanical system ever designed. The fuel production plant would need power, a great deal of power. A facility capable of generating enough propellant to launch a crew of 4 or 5 people from Mars and begin the journey home might require between 100 and 200 kilowatts of continuous electrical power. That is roughly the equivalent of powering 100 average homes, running without interruption, day and night, for a year or more. Solar panels are one option, but Mars receives less than half the sunlight that Earth does, and dust storms on Mars can last for months, reducing available sunlight by 50 to 99%. The Mars rover Opportunity was lost in 2018 when a global dust storm covered its solar panels, and the batteries could no longer maintain power to the heaters. The rover froze and never woke up. A fuel production plant dependent entirely on solar power faces the same risk. Nuclear power is more reliable. Small nuclear reactors currently in development could provide the steady, continuous power needed regardless of weather or dust. But they add complexity, they add mass, they raise safety considerations for the launch itself, and they require their own cooling systems and shielding in the Martian environment. And all of this infrastructure, the reactor or the solar arrays, the chemical processing equipment, the storage tanks for cryogenic propellants, the sensors and control systems and maintenance robots, all of it needs to operate autonomously for years, before any crew even leaves Earth. It needs to work in temperatures that swing from 20 degrees Celsius above zero at midday to 125 degrees below zero on winter nights at higher latitudes. It needs to work through dust storms and radiation and the slow accumulation of wear and degradation. And at the end of all of that, it needs to have produced not a few kilograms of propellant, but tens of thousands of kilograms, 30 to 50 metric tons, the mass of 35 automobiles manufactured from Martian air and Martian ice by machines operating alone on another planet. If any part of that system fails, if a pump breaks, if a reactor goes offline, if a dust storm lasts too long, the fuel production stops and the timeline extends. And the crew on the surface, waiting, consuming their life support supplies, their food, their air, their carefully rationed everything, begins to face a different and darker kind of arithmetic. This is the shape of the problem. Not one obstacle, but a cascade of interconnected ones, each depending on the successful resolution of the one before it. Getting there requires the journey. Landing requires the precision. Surviving requires the life support. Getting home requires the fuel. And producing the fuel requires years of autonomous operation by complex machinery in one of the harshest environments in the solar system. The mission does not fail at a single dramatic moment. It could fail slowly, through accumulation, through the patient grinding away of margins that were never very wide to begin with. And on Mars, with Earth 6 to 20 minutes away by radio and 6 to 9 months away by spacecraft, there is no rescue. There is only improvisation and ingenuity, and the particular kind of courage that consists not of a single bold act but of continuing, day after day, in the face of a situation that offers no easy resolution. Take a slow breath. Let all of that settle. The numbers, the distances, the complexity, the sheer weight of what we are describing. You do not need to hold all of it precisely. Let it rest in you like the awareness of something vast and real that exists whether we are thinking about it or not. We are just beginning to understand the full shape of this problem. And beyond the technical questions lies something else entirely, something more human, more intimate, and in some ways more difficult to think about clearly. Something that has to do not with fuel production or orbital mechanics or radiation exposure, but with the question of what it means to leave a place and know, with complete certainty, that you are never going back. We will get there. The dark is patient. And so, tonight, are we? There is a word that most people use without thinking very carefully about what it means. The word is home. We say it casually, the way we say familiar things that have been true for so long they have stopped requiring examination. Home is where you sleep. Home is where your things are. Home is the place you return to at the end of the day, the place that knows the particular shape of your habits and your preferences and your history. But there is something deeper in that word than any of those descriptions fully captures. Something that has to do with belonging, with the sense that a particular piece of the world is connected to you in a way that no other piece quite is, that you came from it, that it shaped you, that it holds the people and the memories and the sensory textures that constitute who you are. Home is the place you can always go back to, unless you cannot. The first human beings to travel to Mars will face a question that no explorer in the history of our species has ever had to answer in quite the same way. Not merely the question of whether they will survive the journey, or whether the technology will hold together, or whether the mission will accomplish its objectives. Those are serious questions, but they are technical ones, amenable in principle to engineering and planning and preparation. The deeper question is this: are you willing to leave the only world your species has ever known, knowing with complete certainty that you will never stand on it again? Not, probably never. Not very unlikely. Never. The door closes behind you. The spacecraft departs. And the Earth, which has been home to every human being who has ever lived, every ancestor going back millions of years, shrinks behind your window until it is a point of light, and then nothing you can distinguish from the other points of light, and then nothing at all. Consider for a moment what you would be leaving. Not abstractly, but specifically. Think about the particular textures of life on Earth that we rarely notice because they are simply always there. The feeling of wind on your skin. Not recycled, filtered, temperature-controlled air moving through a vent, but actual wind, with the smell of wherever it has come from, the ocean, or a field, or a forest, or a city, carrying its own information about the world. Rain, the sound of it, and the smell of it, and the feeling of it when you are caught in it without an umbrella, and you are briefly annoyed, and then briefly delighted because it is just rain, just ordinary water falling from ordinary clouds over an ordinary afternoon. Green things growing. Not crops under LED lights in a pressurized greenhouse, monitored carefully because they represent calories and oxygen and survival, but plants growing because the soil and the sunlight and the rain have simply allowed them to, without anyone's permission or intervention. The sound of other people, strangers, the background hum of a world with 8 billion inhabitants going about their business all around you. All of that ends. On the day the spacecraft departs for Mars, it ends permanently and completely. And the person inside the spacecraft knows this. They have chosen it. They have signed whatever forms need signing, endured whatever psychological evaluation is required, said whatever goodbyes need to be said, and then walked through that final doorway into a future from which there is no return. Why would anyone do that? It is worth sitting with that question for a while, because the answer is not simple and not obvious, and because understanding it is essential to understanding what a Mars mission actually is and what it would actually mean. When Mars One, a private organization founded in the Netherlands in 2012, announced plans for a one-way mission to establish a permanent human presence on Mars, they received more than 200,000 applications from people in over 140 countries. 200,000. Teachers, engineers, students, military veterans, doctors, artists, people from every background and every age group and every corner of the world. Some were scientists with the kinds of credentials you might expect for something like this. Others had no particular space-related qualifications at all, but possessed a willingness to learn and an appetite for exactly this kind of challenge. What they shared was a readiness, a genuine and apparently freely chosen readiness, to leave Earth forever for a chance to be part of something that had never been done before. Mars One ultimately failed, for reasons that had more to do with finances and organizational capacity than with any shortage of willing pioneers. By 2019, the company had declared bankruptcy, having raised nowhere near the money needed and having built none of the hardware required, but the applications remained. 200,000 people who looked at the prospect of a permanent, one-way relocation to a cold and airless desert world and said yes. This tells us something important about human nature, something that the technical specifications and the orbital mechanics and the propellant chemistry cannot fully capture. People are capable of choosing difficulty over comfort, distance over familiarity, risk over safety, when the thing they are choosing it for seems to them sufficiently meaningful. This is not irrational. It is not a malfunction or pathology. It is one of the most consistently human things there is, the capacity to place something larger than your own immediate well-being at the center of your choices. History is full of this. The people who crossed the Atlantic on the Mayflower in 1620 understood, in the way that people understand things they cannot fully articulate, that they were probably not going back to England. The journey was brutal, the destination was unknown, the mortality rate among early colonial settlers was devastating, and still they came, wave after wave of them, drawn by religious conviction or economic desperation or simple hunger for something different from what they had. The pioneers who traveled the Oregon Trail in the American West during the 19th century undertook journeys of months through territory that was frequently hostile, leaving behind everything familiar, knowing that whatever waited at the end was nothing they could have fully prepared for. Ernest Shackleton, recruiting for his Antarctic expedition in 1914, described the conditions honestly in his advertisement. Men wanted for hazardous journey, small wages, bitter cold, long months of complete darkness, constant danger, safe return doubtful. He received thousands of applications for 28 positions. They knew. They went anyway. The first Mars colonists would stand in that tradition. Not tourists, not passengers, not people to whom something is happening, but pioneers. People who have looked clearly at the costs of a thing and decided that the thing is worth the costs. They would understand that they are trading one life for another. The familiar life, with its comforts and its connections and its ordinary pleasures, exchanged for an existence that is harder and stranger and more isolated than almost any human being has ever experienced, but that is also, in its own way, extraordinary beyond any ordinary measure. Think about what they would gain. They would be the first human beings to live on another world. Not to visit, not to spend a few hours planting a flag and collecting samples. To live, to wake up on Mars and go to sleep on Mars and wake up on Mars again, day after day, as Martian residents in the most literal sense. They would see things that no human eye has ever seen. The Martian sunrise, smaller and paler than the one we know, but real, genuinely occurring on the surface of another planet. The two small moons of Mars, Phobos and Deimos, racing across the sky in ways that have no Earth equivalent. The landscape of Olympus Mons, the largest volcano in the solar system, its slopes extending so gradually that you might stand on its caldera without being able to see its edges, the curvature of the planet hiding them below the horizon. The Valles Marineris, a canyon system so vast that the Grand Canyon would fit inside one of its side branches like a small room inside a cathedral. They would have the chance to answer questions that humanity has been asking for as long as we have been capable of asking them. Did life ever exist on Mars? Billions of years ago, Mars was a different world, warmer and wetter, with rivers and lakes and possibly a shallow ocean in its northern lowlands. It had a thicker atmosphere, a magnetic field that shielded its surface from radiation, and conditions that might have been suitable for life to begin. Then something changed. The magnetic field weakened and eventually failed, probably as the planet's core cooled and lost the churning motion that generates magnetic protection. Without that shield, the solar wind gradually stripped the atmosphere away. The water froze or escaped to space. The rivers and lakes disappeared over millions of years, leaving behind only the channels and basins that record their passage like old scars. The planet became the cold desert it is today. But life, once it begins, is persistent. Traces of past life can survive for enormous periods in the right conditions. Fossils in sedimentary rock, organic molecules preserved in ice or in ancient mineral formations. Perhaps, in the most optimistic scenario, actual living organisms in deep underground aquifers where liquid water might still exist, kept liquid by geothermal heat deep below the frozen surface. A human geologist on Mars, able to select samples on the spot, to follow interesting formations wherever they lead, to make the kind of real-time decisions that no robot with a 20-minute communication delay can make, would have a fundamentally different capacity to search for these traces than any remote-controlled rover. The flexibility and adaptability of a human mind, working in the field, responding to what it actually sees rather than to what a camera transmitted back to Earth, represents a genuine scientific advantage that no current technology can fully replicate. But let us also be honest about what life on the Martian surface would actually be like, day to day, in the years between landing and whatever comes next. Because the extraordinary does not last forever. The novelty fades, and what remains is simply the life you are living, in the conditions you are living it in, for as long as you are alive. The habitat would be small. It would have to be, because every cubic meter of pressurized, heated, radiation-shielded interior volume represents mass that had to be launched from Earth and landed safely, and mass is the currency that everything in space exploration is priced in. The first colonists would live in a space roughly comparable to a large apartment shared among 4 to 6 people, with the critical difference that going outside requires full environmental protection at all times and is never casual, never spontaneous, never a matter of simply opening a door and stepping into the world. The air would be recycled. The water would be recycled. The food would come primarily from stores brought from Earth, supplemented by what could be grown in pressurized greenhouses under carefully managed conditions. Lettuce and spinach and radishes and tomatoes, perhaps potatoes, perhaps rice or wheat if space and yield calculations allow. The soil would be processed Martian regolith, the powdery surface material of the planet, chemically treated to remove perchlorate compounds that are toxic to plants, and supplemented with organic matter produced by the colony itself through careful recycling of biological waste. Growing food on Mars is not farming in any sense we are accustomed to. It is chemistry and engineering, and careful management of a biological process that is trying to happen in an environment that is not designed for it. Maintenance would be the background condition of daily life, the thing that is always either being done or being planned or being deferred because something more urgent has come up. Spacesuits develop small leaks that grow into larger ones if not caught early. Air recycling systems accumulate contaminants that require periodic cleaning. Water purification filters clog with minerals dissolved out of the regolith. Solar panels accumulate dust that reduces their output, and on Mars there is always more dust arriving than you have finished removing. Every system in the habitat has a finite lifespan and will eventually fail, and in an environment where failure can mean death, within hours or days, redundancy is not a luxury but a fundamental design requirement. The colonists would need to be, each of them, something like a general practitioner of survival, not a specialist in one field, but a person with working knowledge of medicine, engineering, agriculture, geology, chemistry, and whatever other disciplines the specific circumstances of the mission require. They would train for years before departure, accumulating knowledge and skills in ranges that no single person is typically expected to master. And then, on Mars, they would apply that knowledge under conditions that no training exercise on Earth can fully replicate, because Earth training exercises always have the option of stopping when things go too wrong. Mars does not offer that option. Consider what happens if someone becomes seriously ill. On Earth, appendicitis is a routine surgical procedure. A few hours in an operating room, a few days of recovery, and the patient goes home. On Mars, with no hospital, no fully trained surgical team, no blood bank, no anesthesiologist, no intensive care unit, appendicitis becomes a potential death sentence. The crew would have one member with medical training more extensive than the others, equipped with surgical tools and medical supplies chosen carefully for their combination of utility and mass efficiency. That person would not be a surgeon in any complete sense. They would be a generalist who has received the best preparation that years of focused training can provide, facing a procedure that even experienced surgeons perform in teams with specialized support. Telemedicine could help. Video consultation with specialists on Earth, guidance from the best medical minds available. But the communication delay renders real-time guidance impossible. When Mars is at its farthest from Earth, a question asked and answered takes 40 minutes round trip. In a medical emergency, 40 minutes is an eternity. The person with the medical training would be working from pre-recorded instructional material, from detailed written protocols prepared before the mission, from their own judgment, and from whatever the other crew members can contribute in the role of assistance. They would be, in the deepest sense of the phrase, on their own. Radiation accumulates. The Martian atmosphere, thin as it is, provides some shielding, perhaps equivalent to being behind a few centimeters of water. But cosmic rays penetrate it, and the energetic. Particles of solar flares penetrate it, and they penetrate spacesuits as well. A year on the Martian surface exposes a person to roughly 80 times the annual radiation dose that someone receives living at sea level on Earth. The increased cancer risk is real and measurable and cumulative, meaning that every day adds to a total that never decreases. The colonists would monitor their exposure carefully, spend time underground or behind added shielding when solar activity increases, limit their time in spacesuits when alternatives are available. But they cannot eliminate the exposure, only manage it. They are accepting, as a known and deliberate condition of their choice, a meaningfully elevated lifetime risk of cancer. Have you ever wondered what it would mean to accept that kind of trade consciously? To look at a risk clearly, to understand it fully and to decide that what you are trading it for is worth it? Most of us manage risk by not looking at it too directly. We drive cars while understanding abstractly that accidents happen. We eat foods that are not perfectly healthy while understanding abstractly that diet affects long-term health. We avoid looking at the actuarial tables. The Mars colonists would not have that option. The risks would be specific and documented and constantly present, and they would choose them anyway, every day by continuing to live in the environment they chose. Psychological health is perhaps the most underappreciated challenge of the entire enterprise because it is the least visible and the most difficult to plan for precisely. Research on people living in isolated, confined environments, on polar research stations, on submarines, on the International Space Station, consistently shows that after about 6 months in such conditions, measurable changes begin to occur. Small irritations that would be trivial in a normal social environment become significant. Sleep patterns deteriorate. Cognitive performance declines in subtle ways. Depression is more common. The absence of privacy, of genuine solitude when wanted, of the ability to simply leave a situation and go somewhere else begins to wear on even the most psychologically resilient people. And 6 months is the short version. The first Mars colonists would be living in a confined habitat with the same small group of people for years, the same faces every morning, the same voices, the same habits, including the ones that are slightly annoying, the way someone clears their throat before speaking, the way someone else always takes slightly more than their share of the better food, the way a third person always has a particular opinion about how things should be done and always eventually brings the conversation around to it. In ordinary life, these small frictions are manageable because you can get away from them. You can go for a walk, visit a different part of town, spend an evening with different people. On Mars, there is nowhere else to go. The friction accumulates. Conflict would be inevitable, and managing it would be a daily practice, as essential as any maintenance schedule. The colonists would need conflict resolution skills that go beyond what most people are trained for. The ability to address resentments before they harden into something structural. The capacity to disagree about important things without allowing the disagreement to erode the working relationship that survival depends on. The willingness to forgive small things quickly, because holding grudges in a sealed habitat is a luxury the situation does not permit. Interpersonal attraction would also be part of the reality, acknowledged or not. Put people together in intimate proximity for years and emotional bonds form, including romantic ones. The question of how to manage this in a small group, where the emotional dynamics of any relationship affect everyone, is not one that training can fully prepare for. Mission planners have discussed various approaches, sending couples whose relationships are already established and stable, careful psychological screening for compatibility, clear agreements made in advance about behavior and expectations. None of these solutions is complete. Human beings in extreme circumstances do not always behave according to agreements made in calmer ones. And throughout all of this, every day, is the awareness that help is at minimum 6 months away. Not a phone call away, not a drive across town away. 6 months of travel. Away, assuming a spacecraft is already fueled and ready and the launch window is open, which it would not always be. If the habitat suffers a serious breach, if a critical system fails irreparably, if the crew faces a situation that genuinely exceeds their collective capacity to handle, there is no one coming. Earth can offer advice, condolences, and eventually, if the situation is not immediately fatal, a rescue mission that takes the better part of a year just to arrive. In the most acute emergencies, the crew would already know the outcome before Earth even receives their distress call. This is not meant to be frightening. Lying in the dark tonight, none of this is happening to you. You are warm and safe, and the world outside is the ordinary world, full of its ordinary distance and ordinary difficulty. But it is worth understanding clearly what we are describing when we describe a Mars mission, because the scale of what the first colonists would be taking on shapes everything about what the mission means and what it would require of them as human beings. And yet, they would go. Some of them are perhaps alive right now, doing something entirely ordinary, unaware that in 20 or 30 years, they will be among the first people to live on another planet. They might be students, or engineers, or doctors, or teachers. They have not yet begun the training that will occupy years of their lives. They have not yet said the goodbyes that will be the last goodbyes. They are simply people, living their lives on Earth in the ordinary world for now. There is something deeply moving about that, if you let yourself feel it. The ordinary lives that will become extraordinary. The people who do not yet know what they are going to choose. The future that is already somewhere in the direction we are heading, waiting to be inhabited. Consider for a moment what it means to think about permanence. Not the permanence of stone or of stars, but the more intimate permanence of a choice that cannot be unmade. Every goodbye the first colonists say before departure is a final goodbye, whether it is acknowledged as such or not. Every last look at a piece of the earth they love, the particular light of an afternoon in a city they grew up in, the smell of a specific season, the sound of a voice they will not hear again except through the compression and delay of digital transmission across hundreds of millions of miles. Every one of those last looks is really the last. And yet the research on people who have faced similar kinds of permanent departure, not to Mars, because no one has done that, but to Antarctic stations for a year of complete isolation, to submarines for months beneath the surface, to the International Space Station for half a year of weightlessness and distance, suggests something interesting about what actually happens to people in extreme circumstances. They adapt, not without cost, not without struggle, not without the genuine grief of what is left behind, but they adapt. Human beings are, among all the creatures that have ever existed on this planet, the most behaviorally flexible. We have colonized every environment Earth offers, from the Arctic tundra to the equatorial rainforest to the high mountain plateaus, and we have done it not by changing our biology, but by changing our behavior, our technology, our culture, our way of understanding the environment we are in. Mars would be the ultimate test of that adaptability, not for a season, not for a year, but for life. The colonists would need to build, essentially from scratch, a way of living in a place that is hostile to life in almost every dimension, and they would need to do it not just technically but humanly, creating not merely a survival system but something that functions as a community, as a society in miniature, as a place where people can find meaning and connection and the kind of ordinary satisfactions that make life worth living in any environment. They would create rituals. The landing anniversary, celebrated every Martian year. Birthdays. Successful harvests from the greenhouse. The first time a new kind of crop was grown. The first exploration of a new geological feature. Small ceremonies marking the passage of time and the accumulation of experience, giving structure to days that might otherwise blur together in the sameness of the habitat and the routine. They would create their own vocabulary, words for Martian phenomena that have no Earth equivalent, a shorthand that emerges organically from shared experience and shared necessity. They would tell each other stories, because stories are how human beings make sense of their lives, and the story they were living would be unlike any story any human being had ever lived before. And somewhere in all of that, somewhere between the maintenance schedules and the medical monitoring and the greenhouse management and the geological field work and the conflict resolution and the careful rationing of everything, something recognizable as a life would take shape. Not the life any of them had before, not the life they might have had if they had made different choices, but a life nonetheless, inhabited fully, with the particular intensity that comes from knowing exactly what you gave up to be living it. That intensity is not nothing. In fact, it might be something that most lives, comfortable and ordinary and full of the options that come from living in a world that does not require daily vigilance just to survive, rarely achieve. The absolute clarity of knowing what you are doing and why you are doing it. The absence of ambiguity about whether your work matters. The inescapable connection to the people around you, because your survival and theirs are genuinely intertwined in ways that most human relationships never quite are. These are not compensations for what is lost. They are not sufficient to make the sacrifice painless or the loss of Earth easy to bear, but they are real, and they are the kinds of things that would fill the years and that the colonists would hold on to when the difficulty was heaviest and the distance most felt. Let the story rest for a moment. Let the distances settle back into abstraction, the way very large things do when you stop trying to grasp them all at once. The habitat is small and warm in the dark of the Martian night. The two small moons move across the sky outside, faster than any moon should move because they are so close to the planet that their orbits are swift. The colonists are asleep or working, or talking quietly about something ordinary. Earth is a bright point of light in the Martian sky, distinguishable if you know where to look, indistinguishable from everything else if you do not. They made a choice. It was a permanent choice, and they knew it was permanent when they made it. And in making it, they stepped into a story that will still be told, in one form or another, for as long as anything we have built manages to endure. We are not finished with this story. There is more to understand, more to feel, more to think about slowly in the dark, about what comes after, about what grows from the seed of those first permanent footsteps, about the children who will be born into a world that is not Earth, who will look up at a pale blue point of light in the Martian sky and understand it the way we understand a story about somewhere we have never been, as real but remote, as ours but not quite home. About what it means for our species when the first word that is not Earth begins, for someone to mean home instead. Let the darkness be gentle around you. Let your thoughts go wherever they want to go. We will find the end of this together, softly, in the third part of the journey. There is a question that sits beneath all the technical details, beneath the orbital mechanics and the fuel chemistry and the radiation exposure tables, a question that does not have a number attached to it and cannot be resolved by any amount of engineering. It is the question of what we are, as a species, what we are capable of choosing, what we are willing to become, and it surfaces most clearly when you try to imagine, not in the abstract but specifically and personally, a human being sitting in a spacecraft as it accelerates away from Earth, watching the planet of their birth shrink in the window behind them, knowing with complete and irreversible certainty that what they are watching is the last they will ever see of it. What is happening inside that person? What are they feeling in the minutes and hours after the point of no return has passed? Not fear, necessarily, though fear is certainly there in some measure, something more complex than fear, something that might be closer to the particular quality of attention that comes when you are fully present in a moment that you know will not come again. The way certain moments in ordinary life suddenly reveal their own weight, a last conversation with someone, a final evening in a place you are leaving, the moment just before something changes forever, except that for the Mars colonists, the entirety of life from that point forward has that quality. Every moment is a moment that is happening on the other side of the departure. Every experience is an experience that is occurring in the new life, the life that was chosen, the life that begins with the shrinking of a blue point of light behind a spacecraft window and does not, and until the body gives out on the surface of another world. Let that settle in you slowly, not with anxiety, but with the kind of quiet wonder that very large things sometimes produce when you allow them to simply be large, without trying to make them smaller or more manageable than they are. We have talked about the technical challenges, the fuel production, the radiation, the medical limitations, the psychological weight of confinement and isolation and permanent distance. We have talked about the reasons a person might choose this anyway, the pull of exploration, the hunger for meaning, the particular temperament that finds the ordinary world too small. Now, let us think about what happens after. Not after the mission ends, because in an important sense the mission does not end for the people who remain on Mars, but after the initial period, after the novelty is faded and the colony has settled into something like routine, after the first year becomes the second, and the second becomes the fifth, and the question is no longer whether this is survivable, but what kind of life it actually is. The first generation of Mars colonists would age on Mars. This is simple and obvious, but worth dwelling on. They would not return to Earth to grow old. They would not have the option of retiring somewhere warm, of spending their later years near the people they grew up with, of walking through landscapes that hold the memory of earlier times in their lives. They would age in the habitat, in the low gravity that would gradually alter the architecture of their bones and muscles, under the accumulated radiation dose that would write its slow effects into their cellular biology, among the same small group of people who arrived with them and whoever came afterward on subsequent missions. Their bodies would change in ways that medical science can anticipate only partially. Bone density would decrease, muscle mass would shift, cardiovascular systems would adapt to the lower gravitational demands. The immune system's behavior in a low radiation shielded, high cosmic ray environment over decades is not fully understood, because no one has ever lived that way before. They would be, in a very real sense, the data. Their health outcomes over years and decades would tell future mission planners things that no Earth-based study could reveal, because the specific combination of low gravity and high radiation and isolation and the particular diet available on Mars has no exact analog anywhere on Earth. This is one of the quiet dignities of what the first colonists would be doing, not just surviving, but contributing. Every medical measurement taken, every bone density scan, every cognitive assessment, every blood panel, every observation of how the body responds to Martian conditions over years of actual exposure would become part of the knowledge base that makes subsequent missions safer, that helps later colonists arrive better prepared, that allows the medical protocols for long-duration Mars habitation to be refined into something more effective than anything that could be designed from the surface of Earth. They would know this. It would be part of how they understood their own lives, the contribution that was not finished when the spacecraft landed but continued through every day of their existence on the planet. They are not merely residents. They are pioneers in the most complete sense, people whose every experience is information, whose adaptation or struggle or survival or death teaches something that cannot be learned any other way. Have you ever thought about what it means to contribute something that you will never see the full consequence of? To plant a seed you will not live to see become a tree, or to lay a foundation for a building whose upper floors will be added by people not yet born. This is what the first colonists would be doing, and they would know it, and that knowledge would be one of the things that gave the daily difficulty its meaning. The habit is small and the work is hard, and the distance from everything familiar is permanent. But what is being built here, slowly and imperfectly and at enormous cost, is something that will outlast every individual life that contributes to it. Think about the children. Not children in the abstract, but specific children. The ones who would be born on Mars in the second or third decade of the colony's existence, once the population has grown enough and the habitat has expanded enough and the medical capabilities have developed enough to make pregnancy and childbirth something that can be supported. These children would be born into a world that is, for them, simply the world. Not a strange world, not an alien world, not a world that requires adjustment or grief or the deliberate construction of a new sense of home. Just the world. the place where they exist. They would grow up knowing the particular color of the Martian sky, that butterscotch pink, that deepens toward blue near the horizon at sunset, as the most ordinary thing imaginable. They would know the feel of low gravity not as a novelty or disorientation, but as the simple condition of their bodies, the way things are. They would look up at Earth in the night sky, bright enough to see clearly and understand it the way a person born on an island understands the continent whose lights they can sometimes see on the horizon. Real, certainly. Connected to their own history, yes, but not theirs. Not home. These children would be Martians in a way that their parents could never quite be. The first colonists would always carry Earth with them, in memory and in longing, and in the cellular knowledge of a body that formed in Earth gravity and Earth light. But the children would have no such carried weight. Mars would be simply where they are from, the way each of us is from wherever we grew up, without any sense that this is remarkable or requires explanation. Their relationship to Earth would be mediated entirely through technology and story, images transmitted across hundreds of millions of miles, video calls with relatives who exist on another planet, relatives who age in a different gravity and breathe a different atmosphere and live in a different kind of time, because even the length of a day is slightly different on Mars, 24 hours and 39 minutes rather than 24. Stories told by the first colonists about what Earth was like, the feel of rain, the smell of a forest, the sensation of swimming in something as vast and yielding as an ocean. These stories would become mythology over time, not false, but elevated, transformed by the distance and the retelling into something that carries more weight than simple description. And there is a physiological dimension to this that is worth understanding clearly. Children born and raised in Mars gravity, 38% of Earth's, would develop differently than children raised on Earth. Their bones and muscles would form in response to the gravitational demands actually placed on them, which are substantially lower than what Earth places on its children. By the time they reach adulthood, their bodies would be adapted to Mars in ways that go beyond behavior or preference. Their cardiovascular systems would be calibrated to pump blood against a lower gravitational gradient. Their skeletal structure would reflect the lower loading they experienced during development. If they were to travel to Earth, to stand in the gravity that shaped their parents but not themselves, they would feel 3 times heavier than they are accustomed to. Walking might be possible but exhausting. Running might be effectively impossible. Their hearts might struggle to circulate blood against the increased demand. Earth, for these children, might be not merely unfamiliar, but physiologically overwhelming. They would be Martians in their bodies, not just in their sense of belonging. The planet would have shaped them in ways that make them belong to it in a biological sense, not just a cultural one. This is not a tragedy, though it sounds like one when described from an Earth perspective. From a Martian perspective, it is simply what they are. They are the people of Mars. They live where they live. They are built for where they live. And the question of going to Earth carries for them roughly the same weight that the question of going to Mars carries for someone born on Earth. Theoretically possible, enormously demanding, not something most people would choose or feel particularly drawn toward. Consider what this means for the long arc of human history. For the first time in the 300,000 years or so that anatomically modern humans have existed, a group of people would be developing, over generations, into something slightly but measurably different from the rest of the species. Not a different species, not in any near-term time frame. The genetic differences would be minimal for a very long time, and intermarriage between Earthborn and Marsborn colonists would maintain genetic continuity. But the physical divergence, the result of growing up in a different gravity field with a different radiation environment, would be real and would deepen over generations. Martian humans would be somewhat distinct from Earth humans in their physical capabilities and their vulnerabilities, and the particular way their bodies have been shaped by their world. This has happened before on Earth, when populations were separated by geography for thousands of generations. The high-altitude populations of Tibet and the Andes developed adaptations to thin-air environments that other humans do not have. changes in hemoglobin, in blood vessel density, in the efficiency of oxygen use. These changes occurred over thousands of years of natural selection. On Mars, the divergence would be driven not by natural selection exactly, but by the environmental conditions of development. The way a plant grown in low light develops differently from the same plant grown in full sun. Over generations, this divergence would accumulate, and the humans of Mars would be not a different kind of being, but a different expression of the same kind of being, shaped by their world the way all living things are shaped by theirs. What would their culture be like? This is perhaps the most genuinely unknowable aspect of the whole question, because culture is emergent. It cannot be designed or predicted, only created, through the slow accumulation of shared experience and shared necessity and shared story. The first colonists would bring their Earth cultures with them, their languages and their music and their values and their ways of understanding the world. But those things would immediately begin to be modified by the conditions of Martian life. Language changes when the community of speakers changes. New words emerge for new phenomena. Old words acquire new meanings or fall into disuse because the things they describe no longer exist in the speaker's environment. The Martian colonists would need vocabulary for things that have no Earth equivalent. The quality of light at different points in the Martian day. The particular kind of silence inside a pressurized habitat when all the mechanical systems are running smoothly, which is different from the silence outside, which is technically a silence of near vacuum, but also the absence of a kind of presence that the habitat silence does not have. The sensation of moving in low gravity, which astronauts describe in ways that suggest it requires new descriptive resources. Music would evolve. The acoustic properties of a pressurized habitat are different from those of an Earth concert hall or a living room or an outdoor amphitheater. Sound behaves differently in the atmosphere that would be maintained inside the habitat, which might differ from Earth's atmosphere in composition or pressure. Instruments would sound different. The conventions of musical form that developed on Earth, the rhythms, the harmonics, the expectations about how melody develops and resolves would be available as a starting point, but would not remain unchanged. New forms would emerge, suited to the new acoustic conditions and the new emotional life that Martian existence would require. Art would reflect the environment. The visual artists among the colonists would have access to a palette of color and light. That is simply different from Earth's. The particular orange-red of Martian dust. The way the sun looks small and cold when it is the same star that on Earth appears large and warm. The stars, at night, visible without the atmospheric scattering that makes Earth's night sky the luminous thing it is, which means sharper and in some ways stranger than the familiar sky. The two moons, both small, both moving faster than Earth's moon, creating a kind of visual rhythm in the sky that has no terrestrial equivalent. Literature would grapple with the central experiences of Martian life, the choice that brought people there, and what it meant, and whether it was worth it, and how you understand your life when you have made a permanent and irrevocable decision at the center of it. The relationship to Earth, to a home that exists only in memory and in story, and in the pixel-transmitted images that arrive with a time delay that makes them already slightly old by the time they are received. The relationship between the small group of people in the habitat and the vast, empty world outside, which is immeasurably ancient and utterly indifferent and beautiful in a way that requires new language to fully describe. Political life would develop along lines that Earth political theorists have not yet fully imagined. The first colonists would operate under the authority of whatever organization sent them. But as the colony grew, as second and third generations appeared, as people were born who had no relationship to Earth except through ancestry and story, the question of governance would become impossible to avoid. Who makes decisions? On what basis? With what accountability to whom? The communication delay gives Mars a structural independence that has no Earth equivalent. By the time Earth can respond to a Martian political development, the situation has already evolved. Martian self-governance would not be a concession granted from Earth, but a simple consequence of distance. The colonists would govern themselves because the alternative, Waiting for instructions that arrive 20 to 40 minutes late from a planet hundreds of millions of miles away would be incompatible with any functional society. This independence would deepen over time. A colony of 6 people is dependent on Earth for almost everything. A colony of 600 has meaningful local productive capacity. A colony of 6,000 begins to have the kind of economic and social complexity that makes genuine self-determination possible. The trajectory is clear, and the people who understand it most clearly would be the colonists themselves, who live it every day in the practical experience of making decisions that Earth cannot meaningfully weigh in on in real time. What obligations would they feel toward Earth? This is a genuinely open question. The first colonists would feel strong ties, personal ones, to the people they left behind. But those people would age and eventually die. The second generation would have parents on Mars and grandparents they know only through screens and time delays. The third generation would have great-grandparents on Earth who are legends or memories or names in a family history. The personal connections would thin generationally, while the cultural connections might strengthen through deliberate effort or weaken through the natural divergence of separate communities developing separately. History suggests that colonies eventually seek autonomy, not because of any hostility toward their origin, but because the practical conditions of their existence make self-governance more functional than external governance. The American colonies, the Australian colonies, the eventual independence of every significant colonial settlement in Earth history followed this pattern. Mars would too, probably faster, because the physical separation is so much greater and the communication delay so much more structural in its effects on the possibility of centralized authority. And there is something in that trajectory that is worth sitting with quietly, because it is not a story about conflict or betrayal, but about the natural unfolding of what it means to be somewhere long enough to belong to it. The first colonists choose Mars. Their children are born into Mars. Their grandchildren have never known anything else. By the time that third generation is making political decisions, Mars is not a settlement of people from Earth. It is a civilization of people from Mars. The fact that their ancestors came from another planet is part of their history, honored and studied and woven into their founding mythology, but it does not determine what they are now or what they will become. The first colonists would not live to see this. They would die on Mars, in the habitat or possibly outside it, their bodies committed to the Martian soil in whatever ceremony the small community develops for marking the passage of its members. The first Martian cemetery would be a profound thing, a permanent physical record of the people who came and stayed, whose choice to never return is now, in the most literal possible sense, complete. Future colonists would visit it. Martian children would be brought to it the way Earth children are brought to historical sites, to understand something about where they come from and what it cost. The names on those markers would be known for as long as Martian civilization exists, not because the people who bear them were perfect, because they were not. They were human beings with the full range of human complexity and contradiction and ordinary flaw, but because they were first. Because they made a choice that no human beings had ever made before and lived the consequences of it every day for the rest of their lives. Because they went to Mars and they stayed, and in staying they made it possible for everything that came after. Think about what the world would look like from the perspective of those first colonists in their final years. They would be old, their bodies shaped by decades of Mars gravity and Mars radiation, in ways that no body had ever been shaped before. They would look around them and see a community that was not there when they arrived, people who came on later missions, people who were born there, a web of relationships and routines and small traditions that they helped to create simply by being the first ones present. They would see the greenhouses, producing food with a reliability that did not exist in the first anxious years. They would see the habitat expanded, new modules added, new connections built. They would see children who have never worn a spacesuit with that particular first-timer's self-consciousness because they grew up wearing spacesuits the way Earth children grow up wearing shoes. They would see, in the accumulated evidence of years of work and improvisation and survival, the foundation of something that will outlast them. And they might look up at Earth in the Martian sky, that bright, familiar point of light, and feel something that defies simple description. Grief, yes. The grief of permanent separation does not fully resolve. It only becomes familiar. But also something else. The particular piece of a person who has lived in accordance with their deepest values, who has made a choice that aligned what they believed with how they actually lived. They chose this. Every day that was a hard day they chose. Every sacrifice was a sacrifice they agreed to, and the thing they were building, the thing that is visible around them in the habitat, and the people and the slow accumulation of life in a place that had no life before they arrived, that thing is real. The footprints they made on the day they landed are still there. There is no weather on Mars capable of erasing them, no rain, no wind strong enough to move the loose regolith that holds the impression of their boots. Those footprints will be there in 1,000 years, in 1,000,000 years, in 10 million years, when whatever the humans of Mars have become has spread across the solar system in ways we cannot yet imagine. Those first impressions in the dust will still be there, perfectly preserved, as clear and specific as the moment they were made. They are not a monument anyone built. They are simply what happens when a person walks on a world for the first time. The world keeps the evidence. The world remembers, in its patient, geological way, long after the person who made the mark is gone. There is something deeply restful about that when you let yourself feel it. The permanence of small things. The way the universe holds certain moments without being asked to, simply because the physical conditions happen to allow it. A footprint in the Martian dust is not an artifact or a memorial or a deliberate statement. It is just the record of a person walking, and it will outlast not just the person who made it, but everything we have ever built or written or imagined on Earth, because Mars is old and patient and keeps its records in geological time. We are a species that makes marks. We have always made them. Cave paintings that have lasted 40,000 years. Structures of stone that have stood for millennia. We make marks because we are here, and being here means something to us, and we want the fact of our presence to be legible after we are gone. The first humans on Mars will make the most permanent marks our species has ever made, simply by walking, simply by being there, simply by having chosen to go. They will not come back. We have understood, over the course of these hours in the dark, why this is so. The distance and the expense and the fuel and the launch windows and the accumulated complexity of a system that must work for years without failure in order to bring anyone home. But we have also understood something else, something that sits beneath the technical explanation. They will not come back because going back was never what the mission was for. The mission is to stay, to be there, to make Mars the kind of place that can be stayed in, and then to let the staying accumulate into something, slowly, over years and generations, into a civilization. The cost of this is borne by the first people. It is always the first people who bear the greatest cost, who face the unknown most directly, who have the least support from experience or precedent, or the accumulated wisdom of people who have done this before, because no one has done this before. They are the ones who find out what is actually difficult, as opposed to what was predicted to be difficult, which is always a different list. They are the ones who improvise the solutions that future colonists will simply inherit as standard practice, the same way we inherit the solutions our ancestors found to problems we never have to face ourselves. This is the role of the pioneer. Not the glamorous version, though there is glamour too, in the sense of being first, of standing on ground that no human has ever stood on. But the unglamorous version, which is most of it, the daily maintenance, the careful rationing, the managing of relationships under pressure, the medical decisions made without full information, the psychological discipline required to continue, day after day, in an environment that provides no easy comfort and no exit. And yet they continue. This is the most human thing about the whole story. Not the technology, not the orbital calculations, not the chemistry of fuel production. The most human thing is that they continue. that people, given a difficult enough reason and a clear enough purpose, are capable of enduring conditions that would seem to make endurance impossible, that the human capacity for meaning is stronger than the human need for comfort, when the meaning is genuine and the choice is real. You are lying in the dark right now, on the earth that is home to every human being, alive, and to every human being who has ever lived, and to every human being who will live for at least the next generation or two. The air you are breathing entered the Earth's atmosphere partly through the exhalation of trees and partly through the complex cycling of gases that has been going on for billions of years on this particular planet. The weight of your body against the surface beneath you is the weight of Earth's gravity, the specific gravitational field of this specific world, which is the only gravitational field any human body has ever been shaped by until now. This is your home. You belong to it in ways that go all the way down to your cellular biology, and it is beautiful, even in its difficulty, even in its imperfection, even in all the ways it falls short of what we might wish it were. It is the world that made us. And somewhere in the future, not very far away in historical terms, there will be people who belong to another world in exactly this way, who are shaped by its gravity and its light and its conditions the way you are shaped by Earth's, who will look at the planet you are on right now, that bright point of light in the Martian sky, with the same mixture of recognition and distance that you might feel looking at a country your great-grandparents came from. Real, part of the story, but not home. They will exist because some people, specific people, with specific names and specific histories and the full ordinary complexity of human beings, made a choice, a permanent and irrevocable choice, a choice that said, simply and completely, that the future matters enough to pay for it with the present, that the species matters enough to pay for its continuation with one's own return. They went, they stayed, they built something. The footprints are still there in the dust. And somewhere above the surface of Mars, in the dark and cold of a Martian night, two small moons race across the sky, moving faster than any moon should move, casting their faint double shadows on a world that is, for the first time in its 4-billion-year history, inhabited. Let that be the last thought, moving gently through you as you settle into sleep. The universe is very large and very old, and mostly very quiet. But in one small corner of it, on one small red world orbiting one ordinary star among hundreds of billions, the lights in the habitat are dim but burning. Someone is awake, checking a reading, adjusting a valve, making a note in a log that will be transmitted to Earth tomorrow. Someone else is asleep, dreaming of what people dream of when the world they grew up in is hundreds of millions of miles away. They are there. They chose to be there. And in their being there, something changes about what humanity is and what it can become, and how far into the future and how far across the dark the story of this particular kind of creature might eventually reach. That is enough. That is more than enough for tonight. Good night.